One.
All right, guys. Lesson 1.3.2. I'm gonna look at example 1 here. I know some of you don't like my hand and the camera, but there's a specific reason I'm doing it this way this time. So bear with me. All right. So it says if a pendulum swings at 90% of its height on each swing and starts out at a height of 60 centimeters, what is the equation that models this scenario? What's its graph? So it's decreasing by or going down by a percentage, okay, which basically means we're multiplying by a percentage on each swing. So there's two ways we can think about it. All right. So the first one is our sort of, if we're repeating multiplication, again, that's exponential. So we can think about this. Or I told y'all in the last videos that if you're dealing with percentage, you want to think about using the growth or decay with the 1 plus r, 1 minus r. And in this case, you can do that as well. And you would do a then 1 minus r because we're decaying, we're going downhill, right? To the t power. And t in this case, time, but it's interval. So in this case, it's actually each swing. Now, here's where these two things are different and how we can still use them. We actually know the percent that it's going to be each time, right? But now think about what that means it's losing. If a swing is at 90% of the height of its previous swing, that means that it lost 10%. Okay? So we're going to write this one of two ways. Either, I'm going to start with this one. If we're losing 10%, then you would set this up as the initial amount, which is A. So A is 60. Your R is 0.1. 0.10, 10% change to a decimal. Okay. And then T, we don't know because it's still unknown, right? That's our variable that we still have. And of course, Y is the new height. So when we set that up, we get 60 times 1 minus 0.1 to the T, which we can then clean up. Okay. And if you're paying close attention, this rate right here at 90% actually looks like that. Because we know that it's going to be 90% of its height each time, we could have used this one up here and just said that our base, if we realized it, our base was going to be 0.9 because that's the change that we're going to have. Here we're using the variable t, here we're using the variable x, but they're the same thing. All right. Now, that brings me to the next part. There's our equation. And it doesn't matter to me if you use t or if you use x. That's going to bring me to the next part of this, which is I need to figure out how to graph this thing. Okay. Exponentials are a little bit trickier to graph because the numbers don't always work out so nice and neat like they tend to do with linear functions. So I'm going to show you how to use your calculator to help you get a table of values, and then we'll graph it from there. So on these calculators, what you want to do is you want to start by hitting the table key. And it's going to give you this, enter y equals function. Well, we have a y equals function. So 60 times 0.9. Now, the exponent key is right here, this little up arrow key. And I need my variable to be x. The variable key on these calculators is down here. It's got x, y, z, t, a, b, c, and it'll give you x. Okay, we're going to hit enter. And we want to ask it where to start. So what value of x do I want to start at? Well, it's time or swings, right? So I want to start at 0. I want to know my initial starting point and then go from there. Step is what we're counting by. I'm actually going to count by 5s because I want to get a good idea of how this is going to look as we keep going further and further out. Actually, I'll tell you what, let's go back. Let's make the step 1 just so we can really get an idea of what's going on here. Each swing, right? One swing, let's see what happens. And we're going to keep it on auto, which means it's just going to keep filling in for us. We hit OK, and here's our table of values. Okay, 0, 60, 1, 54, and then we're going to keep on going down. So after 5 swings, we've dropped to a height of 35.4294. And we can keep going down. And what you should notice is if it keeps being at 90%, you're noticing that we're not dropping by as much each time. That's what an exponential function does. It's a graph of a curve. And the one thing that will never happen is we're going to get super close to 0, but we're never actually going to hit 0. We'll talk about that a little bit more in depth later. But what I want to do now is graph this. So that's where this calculator comes into play, because you got all these decimals that you're going to be trying to graph, and you're going to want to make sure that you get them as close as possible. So that's the other reason that I brought out. That's the main reason I used the camera instead of the board. It's because I want to be able to show you the calculator. All right. So now I'm going to bring this over to actually graph it. Okay. So I've already done this. So this is the height, right? This is the height of each swing, and then down here is the number of swings. All right. So initially we were at 60. Okay, that one's nice and easy. And again, we'll see if I can't put my calculator there so y'all can see those numbers. And then the next one after 1, which is, I went by 5s down here just because I wanted to see what happened out all the way out at 40. So at 1, we were at 54. So we almost immediately dropped to here. Okay. Well, let's go down to some numbers that are actually on the grid line so we can kind of get a better idea. So we're going to skip a few. We're going to go to 5. I don't want to have 40 little dots here to get this thing going. All right. So I'm at 35.4. So just a little bit above 35 when I'm at 5. So go out to 5, and it's 35.4. So just barely above 35. And guys, you're not going to be able to get these exact. Okay. That's part of the reason I'm showing you this with the calculator. All right. The next one I want to look at is 10. Okay. 20.9, so almost 21. So at 10, we're almost at 21. And as you can see, we're dropping quickly, guys. Very quick drops. All right, let's get out to 15. 12.35. So at 15, we're going to be about halfway between there, right? Right about the 12, 13 mark. It's about the best you can do with that. Then 20, 7.3. So at 20, 7.3 is close, 7, 8-ish, that range, because you're halfway in between 5 and 10 there. 25, 4.3. So just under. Go out to 30, 2.5. You should start to see a pattern here of what we're creating. 1.5. And if I get to 40.8, and if I were to keep going, just say let's do 45, just for fun. 0.5. So what you should see is that we're getting super close to 0, but we're not quite there yet. All right. So the next thing you're going to do is draw that curve, and I'll move my hand in a second. All right. Exponential functions follow a curve, and this thing never crosses the x-axis. It never quite reaches 0. All right. So there's your graph for example 1. And again, that was y equals 60 times 0.9. I put a 0, but you could just let it 0.9 to the x. Okay.